A very good morning to all of you. So once again, I cordially welcome you all for this engineering thermodynamics course, a classroom discussion topic. So today's topic here, I want to discuss about the various types of the thermodynamic processes which are taking place. So the topics which we are going to discuss are how can we define a cyclic process, a reversible process, irreversible process, quasi-static process, and how can you state the zeroth law of thermodynamics and what are the applications of the zeroth law of thermodynamics. So now what is the motivation? That is why we have to study these topics are very important one. So as usual for every class we are discussing about this motivational topics. That is here just you go through the sentence. It is important to know that why all natural processes are taking place according to an irreversible process and the reasons for considering quasi-static process as a reversible process, and also to know the reasons to consider the zeroth law of thermodynamics is the basis for temperature measurement. So this is the motivation. That is, whatever the natural process which is taking place in the universe, so it is according to only irreversible process only, not according to reversible process. So now the question here is why the reversible process cannot happen in the actual practice and why all the spontaneous processes which are taking place in the existing or the actual practice in the universe are taking place according to irreversible process and why we have to consider the quasi-static process is an example of the reversible process and what is the importance of the zeroth law of thermodynamics and its applications. So this is the basic objective of the today's class and I'm expecting the two outcomes from the student. After completion of this lecture, every student should be in a position to differentiate reversible, irreversible, quasi-static and cyclic processes. And the second outcome I'm expecting is explain the zeroth law of thermodynamics principle and its applications. So let us go to the first topic, that is what are the various types of the thermodynamic processes which are taking place. So that is how can you classify the various thermodynamic processes. So first one is the reversible process, second one is irreversible process, and the third one is quasi-static process. So now how can we define the reversible process? So just you go through the PV schematic diagram. There is a property diagram PV. So it is a process when it carried slowly so that the system and surroundings are always in the equilibrium position. So just you see the 1 to 2, it is a continuous line is drawn. So that is indicating the reversible process. So when we can draw a continuous line, so that is we can draw a continuous line whenever we assure that the intermediate path followed by the system, the intermediate path followed by the system is satisfying the equilibrium condition points. That is, it is followed the equilibrium state points. Then we can draw comfortably a property line, that is the process line, from the initial state 1 to the final state 2. So that's why the reversible process here you are able to observe it is by a continuous line. That is, it is locus of all equilibrium states. It is a locus of all equilibrium states. That is, we can join comfortably by drawing a continuous line. So that is a representation of the reversible process. Just you go through the irreversible process. So that is the irreversible process is not followed. That is the intermediate equilibrium state points are not followed whenever a process is taking place according to the irreversible process. So that is you cannot join the initial state point 1 and final state point 2 by a continuous line. So that's why it is represented by a dashed line. So it is a process which takes place rapidly so that the system and surroundings are always are not in equilibrium condition. So that is whenever the intermediate state points are not in equilibrium condition, so you cannot draw a line continuous. So it is a dashed line. So that is the difference of showing the reversible process and irreversible process on any property diagram, that is a PV diagram or TS diagram or anything. And similarly, what do you mean by the quasi-static process? So it is the quasi-static, it is also taken from is a Greek word. So quasi means it is a almost. Quasi means it is a almost. Static, it is a uniform. So it is the quasi-static process says that it is a almost uniform process. So almost uniform process, that is the definition of quasi-static process. So this process is assumed to proceed very, very slowly. Infinite slowness, it is a characteristic feature of the quasi-static process. Infinite slowness, it is a characteristic feature of quasi-static process. So it is assumed to proceed slowly enough during a finite time to appropriate to infinitesimal stages. So here, how can we consider the quasi-static process? Let us take one example. So the example is given very, very clearly. So just you take some piston and the cylinder. So here there are the two stops are provided at the top head of the piston. So that is the piston movement is restricted only up to that particular the stops only. That is beyond that the piston cannot move, and over which we are putting some weights. So whenever, let us say that whenever we are having some 1 kg weight when we place it upon that particular the piston, and when we remove that particular weight suddenly, then automatically there is abrupt changes will take place. So the intermediate paths cannot follow the equilibrium states. So that is an irreversible process. But the same thing I can convert it to a reversible process in such a way that instead of keeping 1 kg weight, I am dividing the 1 kg into some 10 grams. So 10 grams into 100. That is, I am having the 10 grams weight small bots. So these are 100. So 10 grams into 100, that is equivalent to 1000 grams, that is equivalent to 1 kg. Now instead of putting 1 kg at a time, the only one weight 1 kg of the bot, now I am keeping only 10 grams weight into 100. Now I am removing one 10 gram weight. Then the path will not disturb rapidly. Whenever I am removing the 10 grams weight also, still it will sustain to maintain the equilibrium state. That is, it will not move abruptly. That is, we can assume that it is follows the equilibrium state because the deviation is very, very small. The deviation can be neglected. The deviation can be neglected. The deviations from the equilibrium states is infinitesimally very, very small. That is a characteristic feature of the quasi-static process. So once again, you remove another 10 grams weight. So there is no much variation in the existing the path of the equilibrium states. So that's why the quasi-static process can be treated as an example of the reversible process. So that's why the quasi means almost static means is a uniform. So by going through this example, now we can certainly say that. So how can we convert that is irreversible process slowly into the reversible process? So the reversible process attainment is absolutely not at all possible in the actual practice due to the presence of the friction and due to the heat transfer through a finite temperature difference and due to the electrical resistance with resistance. So that is the electrical circuit always there with some resistance. So with all due to all these particular the features, so we cannot in a position to obtain the reversible process in the actual practice. That's why I told you that all the spontaneous processes are basically leading to the irreversible processes only. So cyclic process means that is after the completion of the states, once again it is restoring its original condition back. So that is cyclic process. That is, we are having the process 1, process 2, process 3 and process 4. That is, the initial state of the working fluid is restored after passing through the various state points or after passing through the various processes. It is basically the initial condition is restored back. That is the meaning of the cyclic process. So here, once again, it is very, very important to know that what is the difference between the reversible process and cyclic process. So is there any difference? Because in the reversible process also the initial state is restored back after completion of the process. And in the cyclic process also the initial state is restored back after completion of the process. So in what way the cyclic process is different from the reversible process? That is very, very important one. So in the reversible process, the initial state is restored back along the same path. That is important one. Along the same path, we are able to restore the initial condition. Just you observe here 1 to 2, that is from 2 to 1. That is 1 to 2 and 2 to 1 is possible only along the same line. That is the same path. That is called as the reversible. But whereas in the cyclic process, that is, it is basically undergoing 1 to 2 is a process, 2 to 3 is a process, 3 to 4 is a process, 4 to 1 is a process. That is, we are having the 4 different types of the processes. So here, after executing the 4 processes, once again it is restoring its original condition back after passing through the various processes. That is the difference between the reversible process and cyclic process. So in the reversible process, we are able to restore the initial condition along the same path, but in the cyclic process, we are able to restore the initial condition after passing through the different types of the process. That is along the same path. It cannot be possible in the cyclic process. So that is the difference between the reversible process as well as the cyclic process. So the next important the topic is Zeroth Law of thermodynamics. So how can we Zeroth Law? How can we define the Zeroth Law of thermodynamics? So that is here I told you that it is basically giving you the information about the thermal equilibrium concept, and it is also establishing the concept of the temperature measurement. That is, what are the applications of the zeroth law of thermodynamics? That is, it is basically giving you the information about whether the system is in thermal equilibrium condition or not, and similarly how can we measure the temperature and whether both the bodies are in thermal equilibrium or not. So that particular information we are able to get it from the zeroth law of thermodynamics. And I told you that the thermodynamics is dealing with the 3 different types of the E's. One is the energy, second one is the equilibrium, and third one is the entropy. So here the equilibrium concept is defined or derived only from the zeroth law of thermodynamics. So I told you the importance, but now how can we state the zeroth law of thermodynamics? So that is, if the two bodies are in thermal equilibrium with each other, that is, suppose let us say that A and B are in thermal equilibrium, and B and C are also in thermal equilibrium with each other, then we can say that all the 3 bodies A, B, C are in thermal equilibrium with each other. So that is, first of all, I am taking A and B. So A and B are in thermal equilibrium. So what do you mean by the thermal equilibrium? That is, both are having the same temperature. That is, whenever the 2 bodies are brought into contact with each other, so then after some time, the temperature of body A and body B will remain same. So that let us say that is the equality of the temperature we are able to maintain between the 2 bodies A and B. And similarly, B and C bodies are also brought into contact with each other. Then after some time, so we are able to say that they attained a common temperature. That is, now both the bodies are also in thermal equilibrium with each other. Now we can say that without bringing body A and body C into contact with each other, we can say that all the 3 bodies A, B, C are in thermal equilibrium with each other. So that is the beauty of the zeroth law of thermodynamics. So it is giving us information about the thermal equilibrium, and similarly it is also giving us the information about the temperature measurement. So you can see here thermometer is there. So that is the thermometer measurement, that is the temperature measurement is also possible with the help of the zeroth law of thermodynamics. So these are the topics which we discussed in the today's class. So that is the reversible process, irreversible process, cyclic process, quasistatic process, and the zeroth law of thermodynamics and applications. Now, based on these topics, what type of the questions were asked in the previous GATE examination? Let us say that the first question, an engineer proposed a new temperature scale in which the ice point of the water is taken as 200 degree Q and the steam point is 500 degree Q. That is, ice point is nothing but is the freezing point, and the steam point is nothing but is the boiling point. What are the corresponding values in centigrade? For 100 degree Q and 300 degree Q, the relationship between the two temperature scales is linear. So that is the T degree centigrade at 100 degree Q is equivalent to how much? So it is very, very important question. So how can we answer such type of the questions? So that is, we know that there are the various types of the temperature measurement scales are there. One is the Celsius, which is also known as the centigrade scale, and the second one is the Fahrenheit is there, and the Rankine scale is there, Kelvin scale is there. Like that, we are having the various types of the temperature measurement scales are there. So in each and every temperature measurement scales, we are having a separate freezing point and separate boiling point. So here he mentioned that is the ice point. Ice point, just now I told you that it is nothing but is a freezing point. So here in the Celsius scale, normally the freezing point of the water is equivalent to 0 degree centigrade. But here he has taken the another new temperature scale, that is the Q. So in the Q temperature scale, so the freezing point of the water is 200, but in the Celsius scale it is 0. And the boiling point according to the Celsius is 100 degrees centigrade. That is, I am giving you all these values at atmospheric pressure conditions only. So if the atmospheric pressure conditions vary, automatically this freezing point and boiling point temperature values also will vary if the pressure varies. These are the standard values with respect to standard atmosphere pressure conditions. So the boiling point according to the Celsius scale is 100 degrees centigrade, but in the Q it is 500 degree Q. So that is, you have to remember what is the freezing point and what is the boiling point in the standard temperature measurement scales in the centigrade or the Celsius or in the Fahrenheit. So now he is asking what is the relationship between the Celsius scale as well as the new temperature scale Q. So now we can say that we know that the C by 100 is equivalent to F minus 32 by 180. That is the relationship between the Celsius as well as the Fahrenheit. That is, how can we got this relationship? That is very, very important one. That is always used to remember Celsius minus the freezing point divided by boiling point minus freezing point. So now what are the values in the Celsius? So C minus 0, because 0 is the freezing point. So C minus 0 is equivalent to C only, divided by the denominator boiling point temperature minus freezing point temperature. So 100 minus 0, that is equivalent to 100. So C by 100, that is equivalent to, so here we are having the Q. So Q minus, what is the freezing point? Is a 200. So Q minus 200 divided by boiling point minus freezing point. So 500 minus 200 is equivalent to 300. So now what we finally obtained, so C by 100 is equivalent to Q minus 200 divided by 300. That is the equation. So now he's asking T degree centigrade at 100 Q. So just you replace Q is equivalent to 100. So then what is the value of the Celsius? So C equivalent to minus 33.33. So like that you have to answer such a beautiful question. Very, very important one. So the second one is, which of the following values of temperature is or are designed as absolute zero temperature? So absolute zero temperature means what? So that is 0 Kelvin. So Lord Kelvin, that is a scientist. So 0 Kelvin, it is absolute zero temperature. And it is also known as 0 Kelvin is equivalent to what? Minus 273.15 degrees centigrade. So that's why both B and D are right answers for the absolute zero temperature. So here, what is the right option for the zeroth law of thermodynamics? So according to Zeroth Law of thermodynamics, what is the statement? It is answer is A, because just now I defined. If the two or more thermodynamic systems are in thermal equilibrium with each other, then they must be in thermodynamic equilibrium, that is a thermal, mechanical and chemical phase with each other. So it is the right answer for the Zeroth Law of thermodynamics question. So like this, we are able to expect some important questions in the GATE examinations, and similarly, it is important in the university level point of view also. I hope the outcomes, whatever I am expecting, so that is from every student should be in a position to differentiate the reversible, irreversible, quasi-static and cyclic process. And similarly, they should be in a position to explain the zeroth law of thermodynamic principle and applications. So that should be fulfilled after completion of the class, and every student should be in a position to solve some basic questions regarding to this particular topic. So with this intention, I hope that everybody comfortably understand the concepts of this zeroth law of thermodynamics and the various types of the processes. So thank you very much for listening this lecture, and once again we will meet you in the next classroom discussion topic. Thank you very much.